Right, okay, a question on vertical circles. Edx M3 January 2010, question 5. Here's the question. Pause the video and have a good read of it. So, it sounds as a simple question. You've just got to show an expression for v squared and find the range of values of t, but you have to be careful with this question. There's a couple of things about it. Firstly, let's just go to a new page where I've drawn it again. To show that v squared is this expression that they've got up here. The top diagram here shows where it starts in this question. It starts at a distance of 2a below this point A, the centre of the circle, with a speed of root 2ag. The green lines, the diagram underneath here, I've just shown it at a general point, and this is the angle they've told us to use, theta with the horizontal. So we have to use energy, conservation of energy, because the tension in the string is doing no work. So it's just Ke plus Pe, Ke plus GPe equals constant. So let's take the level of potential energy, the reference level of potential energy, as the level of A, and the initial GPe is minus mg times 2a, minus 2mga. That's the initial GPe. The initial Ke is a half m v squared, a half m 2ag. The GPe, the gravitational potential energy at the point where the angle is theta, the distance here, this vertical height, is 3a sine theta, and because it's below a, that's negative potential, so call that minus 3mga sine theta, and we've also got the k at this point, which is half mv squared. Right, the m's, I've lost an m, there's an m there, the m's will cancel, and we can rearrange that to get v squared equals, you might like to pause the video and just try this and see if you get the same thing, v squared equals 6ga sine theta minus 2ga, and that, if we take the 2ag out, gives what they've got at the top of the page. So that's v squared. 5 marks for that, and on to the next one, next part. And in the next part, it says find the range of values of t. Now, in lots of these vertical circles questions, the range of values of t just comes down to finding the tension at the very bottom of the circle, because that's where the tension's maximum, and the tension at the top in a situation where it goes in a complete circle. But we don't know that this object goes in a complete circle. Let's have a read of the wording of the question again, just going back. So it says, in the subsequent motion, the string remains taut. That's all it tells us. So we know the string remains taut. Now there's two possibilities for that. I'll come back to the page we're on. Either the string remains taut and it just performs oscillations below the level of the center, like this, or the string remains taut all the way, right round. The only other possibility, you see, is for the particle to get up to about here, and then the string goes slack and it leaves the circle. So let's check whether it does a complete circle, because using the information that the string remains taut, all we have to check is whether there's a v squared at the top. So let's put theta equals, it'll be I'll use minus 90, either minus 90 or 270 to get up to this top point here. V squared there would be minus 6ga, well, it's negative. So it clearly doesn't do a complete circle. So if the string remains taut and it's not doing complete circles, it remains taut and just oscillates below the level of center, like I said here. Right, so the minimum tension will be when it reaches its highest point, and that'll be when it stops instantaneously at rest, when it reaches the highest point of its circular arc. So if V is 0, 6GA sine theta equals 2GA. And that gives us sine theta equals a third. Now to find the tension at that point, in this bottom corner here, I'll just resolve towards the center to find the tension. The usual method, T towards the center minus mg sine theta equals mv squared over r. If V is 0, then T minus mg sine theta equals 0. So T is equal to mg sine theta, which is a third of mg. That's the minimum value of the tension. Now the maximum tension is at the bottom. We've just got room to fit it in here without going to another page. At the bottom of the path, V squared works out to be, when theta is 90, V squared works out to be 4GA. Just check that yourself. And at the bottom, if you look at this diagram over here, the tension is towards the center and mg is down. So we've got, resolving towards the center, T minus mg equals m times 4GA over 3a. And that gives us T equals 7mg over 3. Just check that you agree with that. And that's the maximum value of T at the bottom. So that's what was involved in this part of the question. The minimum value of the tension was as it got to the top of its circular arc, and that's when V was instantaneously 0, and the maximum tension was at the bottom. The marks for this. Okay, let's just have a look here. For part A, there's 5 marks for this, and there was those 5 marks were 2 method marks, 3 accuracy marks, M2, A3. The 2 method marks were for basically using the energy, the conservation energy equation, and for attempting to find the correct potential energy, the correct distances below A. So there's a method mark effectively for that line there, and a method mark in there, and there was accuracy marks, 3 of them altogether. Obviously an accuracy mark for the final answer, and 2 other accuracy marks for getting the correct terms in these equations without being too specific. I think you can see the important point, there was 2 method marks for that section. For the last part, slightly 1 more mark for this, 6 marks for this part. How did it pan out here? For the 6 marks, we only had 2 method marks and 4 accuracy marks. And there was a method mark, let me see here, there was a method mark for finding, for this T minus mg sine theta here, resolving towards the center, and a method mark for figuring out that the minimum tension was where V equals 0, and the top of the arc there, so a method mark up here. The rest of it was accuracy marks, so there was an accuracy mark for finding, let's just use my I don't want to clutter the screen up too much. There was an accuracy mark for finding sine theta, an accuracy mark for finding the V at the bottom, and then an accuracy mark for minimum tension and maximum tension. That was a total of 6 marks. Okay, I hope that was useful. Thanks for listening. There's the usual information about the Further Maths Support Programme.